I'm Al again. This is Martin. We would like to tell you about Tessera, which is the next version of Trillian. I'll start by talking a little bit about Trillian, and as is my theme for the day, I'm going to talk about the good old days, the evolution of it, and then I'll sort of quickly talk about some of the things we might have done differently with hindsight, because hindsight is 2020 after all. And then Martin will take over and tell you actually all the interesting stuff that you'd like to hear about for Tessera. So Trillian's been around since 2016, more or less. As I said before, it's application agnostic because we wanted to encourage the growth and existence of other ecosystems. It was built sort of in a microservices fashion because that's what we did then. So you would end up running a bunch of binaries to host a Trillian log. You'd have your personality binary that implemented the protocol, access control, encodings and whatnot for whatever application it was you were building. That would back onto a Trillian log server, which would be sort of chatting away via gRPC and do the business of submitting things to be integrated to the log. There would be another binary for integrating stuff into the log on a schedule, and then you probably run an etcd, you might run Prometheus, and I don't know, a whole bunch of other stuff. And turns out that was quite a lot of work. So we also made Trillian be multi-tenant aware to try to amortize the cost of having this large set of infrastructure running. Trillian has always been tiles based. It was always tiles internally because it makes a lot of sense when you're storing stuff to group them up together and batch them when you write them. But we never exposed any of that. It was only really a storage implementation detail, which is quite exciting to sort of see it break out of the confines of Trillian and up to becoming a first-class citizen. We'll talk a minute about Tessera, but Trillian's still actively maintained. We know that it's still being used. CT is still running on top of it, and probably will be for at least a little while. And we've made changes recently, like Martin made the change to do the revisionless storage at the beginning of the year, which actually has quite a huge implication for cost savings. That if anybody's running shards for 2026 or whatever, hopefully you'll benefit from that. But there aren't likely to be any new features coming or landing because we're all very busy and focused on the next generation of logs, which we'll tell you about in a second. So what did we learn over the last 10 years? I've sort of hinted at a bunch of it now. But if we were to do it again, we would probably make it simpler in terms of using it from like an application development point of view. We would make it operationally a lot less complex and probably a simpler code base as well, because that obviously makes our life a lot easier maintaining those code bases, and it makes it a lot easier for folks that want to contribute. We'd also make it so that you only pay for what you need. Trillian, was able to scale fairly far in terms of throughput and log size. We would test them up to multiple billions back in 2016. But as I mentioned earlier on, there are other use cases where you actually want to scale down quite a lot. So you don't need to run this big cluster of stuff if you only want to add a thing once a month. So it would be nice to be able to do that too. And then also in terms of complexity, you shouldn't pay for complexity or behaviors that you don't need. So for example, Trillian always has its atomic sort of deduplication mechanism running whenever you submit things. You can subvert that if you don't care about it, but it's always there. And so if you don't need that, you shouldn't have to pay the cost and the storage for it. We also tried to make things be a little bit more infrastructure native or idiomatic. Trillian sort of specifies a bunch of storage abstractions that you need to meet, and they were designed with very much a view towards transactional storage infrastructure. But things move on, there are different things now, and having those abstractions set as they were made it a little hard to implement Trillian storage in terms of other types of storage. We'd also probably change the balance between synchronous and asynchronous API calls. If you're aware, when you ask Trillian to add a thing to a log, it says, yeah, sure, I'll come back, I'll do it in a bit, and then at some point it does it. It turns out that it's quite useful to be able to have that happen a little quicker. So, maybe rather than going fully synchronous and having everything integrated and updated, within the call to add a thing, is there a middle point that we could use? And I think the last thing that we would do is try to make it a bit more opinionated. So we tried to make Trillian able to do whatever it was that you wanted to do, as much as was reasonable. But I think over the years we've learned that there are good patterns and approaches to doing things and some that are not so good. And so we would have probably made it a little more easier to do the right thing and a lot harder to do the wrong thing.
Yeah, that's a really good background on how we got to where we are now. So hi everyone, I'm Martin. And I'm going to give you a quick overview of Tessera. So we've spent most of this year kind of experimenting with different technologies and then designing and then finally building Tessera. And so, yeah, it's kind of quite a thing to be standing here now and sharing our next generation of log technology. So we've got a lot to cover, and a lot of this talk is going to be quite high level. So there'll be parts where we don't have the opportunity to go quite as deep as I'd like, and maybe some of you would. But that said, at the end of all of this, you should have a good understanding of what Tessera is and how you can get started with it. I should have actually spent a little second there talking about this slide. So Tessera is a lightweight Go library for building tiled logs, which is mostly understandable, but maybe there's a few people. If there's anyone in the room that doesn't know what tiles are, then you're going to be quite lost, I think. So we'll start with that. As Al says, tiles have been around for ages. So Trillian uses tiles in the storage layer. So it's been around since at least 2016. And Tessera is also using tiles. So it uses them internally, but the big difference is that it exposes them as a first-class API concept. That was pioneered, I think, first in the Go Sum database, and that's now a spec. And so we expect this to be what logs going forward start using as a kind of a standard API. And so given that significance, I think it's important that we've all got a shared mental model of what tiles are. So strap in. The primary purpose of tiles really is about making it so there's efficient lookup of regions of trees. So whether that's for inclusion proofs or consistency proofs or any other kind of inspection. What we're aiming to do is give each part of the tree an address. So think of that like a postcode or a zip code. It allows somebody to easily just look up a region of the tree and get the data that they need. And if that's all you take away from this slide, that's what tiles are, then that's absolutely great. But some of you have probably spent a bit of time playing with Merkle trees and binary trees and want a bit more of an idea of like how these are constructed. So very quickly, I'm going to go over like how that's laid out. So after this talk, you might want to grab yourself a big sheet of paper and a pencil and draw a binary tree with a couple of thousand leaves on it. And then grab, all your leaves will be at the same level if you've constructed it properly. So that's great. Start there, move about 8 nodes up, get a ruler and draw a line all the way across. And what you'll be left with is a slightly less big binary tree at the top of that line and a sequence of binary trees below that line. And if you keep repeating that as you go up the binary tree, then you'll eventually run out of space and your job is done. So you've now got a coordinate system. So this is our postcodes, right? You can pick a level of the tree. So starting in the bottom left corner, 0, 0. And then we can go up and pick a level, and then we can go across and pick which tile it is that we're looking for. So there's a URL there that shows that we're looking for tile 2, 1. So we start at the bottom left, we go up 2, we go across 1, and that's the tile we're looking for. And as I said, this is all now a spec, and if you want more details on this, then the spec link is there. So that's tiles. Now, hopefully this description makes sense to everybody to a degree, but we're still going to go into details over what it is, right? So we'll start with lightweight. We'll go in order this time. So Trillian's more lightweight, as Al's already talked about this a fair bit, actually, because we've taken this approach of not having a single flexible code base that can adapt to different environments and different storage implementations. But we now have sort of 4 native idiomatic lightweight implementations. 2 of them are cloud native, so we have GCP and we'll soon have an AWS implementation. And we've got cloud agnostic implementation, so we've got MySQL and POSIX file system variety. So while these are sort of 4 different implementations, they share a lot of code around queuing and things like this. And from a user's point of view, which probably concerns most of you, all 4 flavors basically behave the same, and programmatically you use them in very, very similar, the same way. It uses duck typing, so you could swap one in if you started with one and you want to switch over to another. Reads are super cheap. And we'll talk about this a little bit later, but basically this is because of tiles. It makes scaling the read traffic, which usually turned out to be a problem with scaling Trillian, read traffic is now super cheap. And basically the moral of the story is we try and make somebody else do it for you. And so yeah, gone are the days of profiling MySQL queries to optimize the read path. And it's also a lot simpler. So Al's already talked about this, about multi-tenancy. But it used to be the case that you'd have one storage location, and in that storage location, you'd stick multiple logs. There's no need to do that anymore. And that means that when you've got to this point where you've brought up 3, 4, 5 logs and you need to delete one of them, there's no longer this sort of quite a dangerous feeling situation where you want to delete one log and keep the other ones running. Like, understandably, that's quite anxiety ridden, and your playbooks need to be quite detailed to make sure you're not doing a dangerous thing there. So that's gone. Each storage location has a single log in it, so hopefully a lot simpler to operate. So it's lightweight. It's also a library, which is in stark contrast with, as Els talked about again, with Trillian, which we distributed that with these microservices, which we thought we were doing everybody a favor by giving them microservices. Like, hey, you just call that thing, you can write your code however you want, and you call these microservices. And programmatically, I think that is still true, but where it lets itself down a little bit is around the deployment time, which is actually where, you're spending a lot of your time once you've written the code, you're deploying it, and you're maintaining that for years. And if you're not doing it in a way where your idea of what microservices are matches with the way that we package those microservices, then you're going to have a bad time and you're going to have a lot of friction. So we've taken a completely different approach here, which is Tessera is just a library, which means you get to deploy it however you want. So if you want a monolith, you can do a monolith. And if you want microservices, you can go and have all the microservices you want. It also makes it a lot easier to kind of, you can still use a physical machine or VMs and Kubernetes and stuff, but you can also easily now bind this into like native, scalable, elastic kind of front-end technologies, so like Cloud Run, for example. And speaking of scale, you can go from a single instance, but we also support, which we put quite a bit of time into the design of this, into making it so it can work regionally or globally. And that's a really important thing. I think Rasmus talked about this earlier, about how uptime on the logs can be super important. And one way of doing that, of course, is to have multiple logs, but another way is to make sure that your log has more availability. And so having it in multiple regions and globally is one way of doing that. And finally, yeah, there's a little bit about instrumentation. I feel like I'm a QVC salesman or something here going on about this, but but you can do it your way. That's basically the moral of this slide. But whatever build chain you want to use, whatever monitoring libraries, debugging libraries, whatever flag system libraries you want to use, we don't have opinions on that. You can have your own opinions, and we won't get in the way. But where we do have opinions is around the sort of the API that you're expecting to be serving your read API from. So it's tiles. You've probably got that idea in your head by now. And so the big difference is that we're storing the tiles serialized according to the API format, which basically means that at read time, so storage is the read API, and so reading these tiles from the storage and sending them through the API requires basically zero or minimal transformation, which means it scales well and costs you very little. These are the two tiles formats we support. So the tlog tiles API is the one that we expect most new logs to start adopting this and using this one. There's also obviously those in the CT world will be familiar with the CT static API, which is similar but a little bit different, and we support both of those formats. So who can use Tessera? Anyone, but as long as you're using these two log formats, or one of these two log formats, you're not going to use both. And unlike Trillian's been around now for 8+ years, and so there's a lot of people have gone through the onboarding process. Tessera's new, and so you're going to have to be prepared to be an early adopter. I don't think that's too scary because we're all friendly here, but it is just something to sort of bear in mind as you get started. So I think that's enough about the overview of everything. Now we're going to just go into a few little details, right? So this is an example code snippet. I said it was lightweight, and I think this hopefully shows it, right? This is about the extent of the API that you're going to see as a client. The first thing you're going to do, whichever storage choice you've made, is you're going to need to instantiate a storage. In this case, this is obviously using MySQL. And so we call it MySQL new. We pass it a database connection, probably for obvious reasons, and then we need to pass it the signing material that it's going to use for signing checkpoints. That's a varargs construct in Go, so we can pass in other optional parameters there that control things like batch sizes and pushback. So there'll be other little bits supported, but those are kind of as you need them. And then you've got your storage object, great. And then the next part of it is going to be adding stuff to the log. And funnily enough, you do that through calling add. And then you call the add method, and as written there, that code will take your new leaf, add it into the log, and give you back, it stores it temporarily, it sequences it, and gives you back an index. And that is the index that's durably assigned, and you're safe. You can return that to clients or use it as you wish. A short while later, asynchronously, it is going to be integrated into the log and made available through the read API. At the moment, you'll have to wait for that, but by the time we hit alpha, one of the big things we're going to have is a utility for those of you that do need to block until it's made available through the read API. We'll have the utilities there so you can block. But for most people, we think just doing it this way is going to be what you need. Right, the next slide's going to go really quite quickly because it's a demo and we don't have a lot of time. So the purpose of this demo really is to show you how quickly and easy it is to get set up running it. And to get started with playing around with Tessera. So here I'm doing Docker Compose to bring up the MySQL instance. I told you it goes fast. Grab some environment variables so we can make some curl requests off the command line, and then we're going to put a few things in the log. So that 1, 2, and I think 3 is coming up. And then they're sequenced and integrated now, and then we're going to just show a few quick GET requests to prove that the data is in the log. So that's the checkpoint and the tiles, the tile with them in, and then we're going to quickly have a look through with the inspection tool. So that's probably quite stressful, and it wasn't meant to be, but it's just supposed to show you that it is just a handful of commands, right? I did consider dropping that, but then otherwise I'm just showing you this slide that's like, and we've got some examples, right? So that GIF that has what I just showed you there is there, so you can watch it in slow motion or as many times as you want, but the script is also there, so you can you can go through it and follow it yourself, and it is just as easy as Docker Compose and a few curl commands to get started. So that's the command conformance MySQL that I've just demonstrated there. There's also a very equivalent one for GCP and POSIX, so you can get started with those as well and just have a little play with them and see how easy they are to deploy and to just interact with the log. And then there's a few other examples. So all these examples here are written in a way where they have a day job, which is so the conformance is to make sure that our performance and correctness is as we expect. But they also serve like a side gig, and that is making it accessible so that people can understand, come and look at the code that's there. It's intended to be accessible, so you can have a look at it and see what usage of the Tessera's APIs look like. And so I did sort of promise this, and so this is the last slide from me. A quick overview of the 4 different implementations that we've got. Well, I'll go over 3 of them. So GCP uses Spanner. So when you call that add method, they go into the new leaf goes into a Spanner table, and that's where it's durably assigned while it's been sequenced. And then when it's integrated into the tree, it will be moved from there and compiled into a tile that is stored in GCS. So the Spanner table is only used for stuff that's not integrated yet, which means it stays small, and that means your bills can stay small too. And then Google Cloud Storage scales and cost-wise as well, really quite nicely. And then you're just getting Google Cloud's GCS to serve your reading for you. And I think they've got quite good at serving read traffic now. So yeah, AWS, we're going to skip that one right now. But MySQL, obviously this one's a little bit different because you do need to serve a read path. You can't just hook your database up to the internet and expect that to go well. So each of the tiles is stored in a row in the database, and it's a point lookup to get a tile, and the way that it's stored in the row is basically as it's needed for the API. So it's while you do have to serve the read path, it's just a point lookup and very little kind of cycles needed. And then POSIX is just a file system, right? So the log's constructed there. And then if you need to serve it through an HTTP server, like we've had HTTP file servers for quite a while now. We're quite good at that. So that's the way you'll serve that one. So back to Al, throw him under the bus to tell you about the status and the timeline.
Can we have it yet? Basically, yes. It is ready for you to play with it. So please do go and play with it. We're pretty confident in the 3 storage implementations that are there. The AWS one, as Martin mentioned, is coming real soon now. But don't wait for that. Just jump in and start swimming. Performance, it heavily depends on where you're running it. So, we're shooting basically for a minimum bar of 1,000 writes a second on sort of the cheapest configuration that you can have, which should be more than enough for now. It will scale higher if you are willing to pay more. So, for example, with the GCS, GCP storage, as Martin said, we use Spanner. That 1,000 writes will come if you use the smallest possible, cheapest Spanner bill. They recently sort of allowed you to use fractional servers, and so you'll get 1,000 QPS out of 100 Spanner performance units, or whatever it is that they call.
That's writes.
Writes, yes. Reads are obviously just from buckets, and so scale as big as your wallet is. Next steps, as I already said, really for you folks to pick it up and start playing with it, because we really want to know if it works for you, and we really, really want to know if it doesn't work for you. Is it easy to use? Is it tricky to use? What could be better? What's missing? Do you have one of these weird sort of corner cases that can't be satisfied with the API surface and sort of envelope that we have? If so, definitely want to hear from you. And yeah, as Martin said, we have the conformance and example binaries, which will serve as nice, simple entry points for you. It's super easy to run them. They mostly just work with Go Run, Docker Compose, or Terraform if you're into that sort of thing. That is all. Any questions?